Okay, so today I'm going to do the demo of the magic jug. Um, in this one, we're going to pretend that we've got a jug that can produce any type of drink that we would want it to. And we're going to see a series of color changes, and it's a lot of fun to watch. Then after we do the demo, we're going to see actually what the chemistry is behind this demonstration. Just a couple things. Okay, first of all, whenever I'm doing the demo, you're not going to see me. You're just going to see my hand pouring liquid so that you can see things better. Secondly, a lot of hazardous stuff in this demonstration, so we want to make sure, that it's understood that although, first of all, we're talking about a magic jug, it's really not magic, it's all science. And second of all, that we would never ever really drink anything that we would do in the chemistry lab, and I just wanted to make sure that that's all clear. So with that, we're going to go ahead and do the demo of the magic beaker or the magic jug. Okay, so this is going to be our magic beaker. And our magic beaker can quench anyone's thirst. We can make any drink that we want to out of this beaker. It's magic. And so what we're going to do is we're first going to say, okay, what would I like to drink? Well, maybe I would like some Kool-Aid. I don't know. I'm kind of thirsty. I've been working up a sweat getting ready to record this demo, so I'd like to have some Gatorade. Or maybe I'm going to try to be a little healthier and have some apple juice. Or, you know what? It's been a really long time that we've been in the house. Maybe I want to have some wine. Or maybe you just want some water. And you can make all those different drinks out of that one beaker. And I really think that's cool because I like the colors and everything. But, now that we made all these things, it's kind of a mess. So we got to clean them up. So I want to clean everything up. So I'll just pour them all back in this beaker so I can dispose of them properly. Ooh, that's a cool purple color. That's one of my favorites. I don't know what it's going to look like after we pour the apple juice in there. Oh, wait a second. Some of that color went away. Or the wine. Oh, now it's really just a black and ugly color. Oh, we'll pour the water in. Ah, and now the magic beaker is back to where it was. So that's the magic beaker demo. So how did the magic beaker, the magic jug demonstration work? Well, we started out with 5 what looked like were empty beakers to you and a clear solution. And in reality, each of those 5 beakers had a little bit of something in the bottom of it. In one of them there was phenolphthalein, the other thymolphthalein, then there was hydrochloric acid both with and without starch. One beaker with starch and hydrochloric acid, the other with no starch and hydrochloric acid. And then there was some S2O3 thiosulfate in one of the beakers. That's the last one. And they were in this order. And then we had our magic beaker or our magic jug, which had some sodium hydroxide, potassium iodide, and potassium iodate in it. We take that solution, and because it contains sodium hydroxide, it will increase the pH. It's a base. Sodium hydroxide is a strong base, so it will increase the pH, and it'll cause those 2 compounds, phenolphthalein and thymolphthalein, whenever they are deprotonated or they react with a base, they change color. We actually use those in acid-base titrations. So if you've ever done an acid-base titration and you've seen the pink color, you're looking at phenolphthalein. Thymolphthalein is a similar type compound, except it turns blue. And so that's what happened when those first 2 beakers, the solutions poured into the first 2 beakers. The third beaker we pour the liquid into, and we got what looked like was apple juice. In reality, what's going on there is a redox reaction between iodate and iodide that takes place in the presence of hydrochloric acid to form triiodide ion. A lot of times you'll see people talk about the fact that it might be iodine that's produced in this reaction, and that yellowish color could be due to iodine or triiodide ion. because the triiodide ion is in equilibrium where it can react to produce iodine and iodide. So we have either one of those two species that are present. It's not always so clear which one exactly that might be, but they're both very similar and they're both very related. And the one interesting thing about triiodide is that whenever triiodide ion is present is present when starch is around, that it will react with the starch to produce a very dark blue or almost blackish or inkish colored solution. And so what you're seeing is in one beaker there's no starch, so we just get the iodine or triiodide ion produced, and in the other there's starch, and so the starch can then react with the triiodide ion to produce that dark color that we called wine in the demonstration. The thiosulfate doesn't do anything. So it literally just looks like clear solution, so we say that it produces water. Now in reality, all these things are very hazardous, so we wouldn't never want to drink them or anything, but it makes fun and interesting conversation around the demonstration. Now when you start mixing those things back together, all right, when that beaker is empty and now we're going to start pouring the things back in, the hydrochloric acid that's left over from the iodide or iodate reactions, that will make the solution acidic again. So you notice when we added the first two and we got that brilliant purple color that I noted, that's because those two indicator colors are mixing together and you're seeing the combination of the two. But then you added the apple juice and all those colors went away, and that's because the excess hydrochloric acid got rid of any sodium hydroxide that was around, and those two indicators were protonated, and so they changed color back to clear. Then we kept on adding everything, and we got to the end, and we added the thiosulfate, and the thiosulfate will reduce, it acts as a reducing agent on the iodine or the triiodide ion to make it go back to iodide, which is colorless. So everything that we had that was brightly colored now is gone, and we're left with a beaker that looks like that is clear. It has no color to it because all of the products, as we ran those reactions backward, went back to their original clear color. And so that's how the magic beaker or the magic jug experiment or demonstration is performed. I hope you enjoyed it.